I'm going to play Empty Promises in D minor. Wonderful blues player.
I wonder if we're going to get a
Chris
copyright. We're going to get cut off for copyright infringement.
That's a good question. Well, I don't think I'm good enough for that.
Yeah, if you play it so well, the algorithms will get you.
I'll do my best to suck.
Oh, this is going to be great.
It's going to be fantastic. It's too bad we didn't have a topic that I enjoy, because then this show would really be fire.
This is going to be brilliant. Oh my God. Ooh, harmonics.
If I get 10 more steps in taking us live, I'm going to have to automate some of this, because it's getting to be a lot.
Huzzah! I'm now recording.
I have backup copies recording. We are live both on the changelog website and YouTube. We do need to do the sync clap, Matt. You're right.
Yeah. We'll do a clap when Chris gets back.
Yeah, we got to wait.
Hold it. They get mad at us if we do more than one clap. It's a sync once clap.
I can't hold it.
Yeah, you've got to really, once you've started a clap, it's really hard to hold, isn't it?
Ryan's audio is going to be really hard to get the sync out of.
Beautiful.
After we're done with the guitar segment, I can switch back over to the headset audio, which will probably be cleaner.
That's fine, but you need to make sure your recording switches correctly. That makes sense. You might have to do 2 different recordings.
Yeah, that's a really good point.
Feedback.
That was me.
That's the only thing I'm going to get worried about if you're switching, but we can always like do a little pause. You can switch and then you can start recording again.
Yeah, I'll just leave it.
Okay. Let's do the clap then. So we're going to do 3, 2, 1, clap. And this time for real. 3, 2, 1. And then we'll see a spike in our audio waveforms, which is be good. Right. Okay.
Right.
I mean, we're live, so hello everyone who's watching live. This is it. I don't know. Do we have any music apart from this one? Do we have like the go time theme? Is that going to happen?
I don't have any of that set up right now. I can go get it if you really want.
That's all right, mate. We'll just pretend it's there. Okay, I'll do a little intro and then we'll go into it. Let's give the editors some work to do, shall we?
Let's do.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about code generation. Hit it, Brian.
Repetitive code just makes me sick. So code generation always clicked. Write the code that writes the code. As long as you're not using Node, talking about code generation. This is the part where I smash the guitar.
Brilliant. Smash it.
I've done that. I did that at GopherCon.
Oh, yeah.
Seems like an expensive thing to do, I guess, unless you really don't want to fly back home with a guitar.
We went and bought a bunch of the cheapest guitars we possibly could just so that we could smash them on stage.
You're a little quiet now, Brian.
Oh, my bad.
Okay,
Oh,
yeah. If you sort that out.
What you probably need to do is inside of Zoom on the top. Is there like a turn on original sound type thing or turn like something like that?
Turn on original sound. Welcome to
Or the other
live
option is
Zoom
if you
settings.
open up the Zoom settings. Like original sound, I think you see like in the top left, like if you're in gallery view and seeing all the people, it's like the top left there. Or it might say turn off original sound or some sort of like drop down. If you don't see
Anything
that,
on original sound.
that work?
Nope, I don't have one of those.
Okay. You sound better now, but if you go to your settings, go to audio, and then where is it?
It's
Oh,
set
there's a
to
check mark for automatically.
Adjusting microphone volume. It seems to be better now.
Yeah, I was gonna say if you turn that off, it helps. What probably happened is you were playing the guitar, so it probably turned your volume really far down.
Right. Let me turn
That's
it up.
a bit rude, isn't it?
How's that?
I think you're good. Now.
Better.
You seem fine.
Okay.
And you're recording locally, so we can always tweak it there.
I
can
know
hear
I'm
you.
fine, man. I know I'm fine.
I only know about this because it's the issue I had when I would play the music for different stuff. Is it would crank my volume down for like the next 2 minutes. Then.
Yeah.
Makes
Okay.
sense.
I think it's good then. Are you happy with your local recording as well, Brian?
I'm happy with everything, Matt.
Great. Well, that was awesome. So thank you so much to Brian there. Now, let me do proper introductions. You heard him already. Very early Go adopter, co-author of Go in Action, and co-creator of GopherCon, and actually one of the original cast of Go Time. It's only Brian Ketelsen. Hello, Brian.
It's only me. I'm OG Go Time.
Yeah. Yes. Welcome back.
Thanks. It's a little bit surreal being here.
Yeah, it has been so far.
All this guitar playing, and you don't mention that he's in the Gopher band.
Oh,
That's
of
true.
course.
A founding member of the GopherCon band.
How did that come about?
Well, we were thinking about ways to entertain people at the first day after party. And I thought it might be a fun idea to get like a karaoke backup band so that we could just have like one or two Gophers at a time singing or playing an instrument while the band backed us. And it very, very rapidly devolved into us being a whole band. And we hired some professional musicians to step in if we just didn't have enough people for a particular song.
And it was great fun. And of course, in San Diego, the Gopher band played on like a
carrier.
On
the
aircraft
carrier. That was pretty awesome.
That's quite a gig.
Yeah, although I would have to say that's probably the tamest year for crowd participation, that people were busy looking at airplanes and not so busy thrashing with us. It's a little sad.
Oh, well,
I feel like it's going to be hard to or it would have been hard to claim that as a business trip when they look at it and they're like, you were clearly at a rock concert. On stage.
Aircraft carrier.
That's not business.
You can't offset that with your tax. Well, I should also introduce, we're not here alone. You've heard his voice already. John Calhoun's also here. Hello, John.
Hey, Matt.
Welcome back, mate. How are you?
I'm doing well.
Good quality chat as usual, John. We're also joined by Chris Brando. Hello, Chris.
Hi, Matt. How are you?
I'm very good, thank you. Welcome back. What's been going on?
Just life, enjoying February.
Yeah, I've never heard that said. Never heard that phrase before. But well, that's great. I'm really excited about this episode because we're talking about a subject that I'm really interested in. And that is, as we heard from our excellent opening song, code generation. So for anyone that doesn't know what code generation is, who wants to take a stab at explaining what do we mean by code generation? Aren't we all generating code all the time?
Code generation is writing code that writes the code.
Ooh, isn't that a bit dangerous, Brian? Like sort of getting into Terminator territory?
Well, it's a little bit like Barry Manilow writing the songs that make the whole world sing. I write the songs. Yes.
Yeah. So a program that writes programs. So why wouldn't we just write the programs? What's the advantage of doing it in that strange way?
I like to imagine this all started when somebody had a manager who gave them raises based on how many lines of code they wrote. So they're like,
Yeah.
I'll write some code that'll write some code, and then I'll get a big raise.
Oh, clever. I did actually once get lines at school and they let me do them on the computer. So I just copy and pasted and printed out the lines and they accepted it. Because I don't think they knew how copy and paste worked.
Nice.
Yeah. So maybe it was something like that.
Now, when you say you got lines, does that mean you were forced to write out a sentence manually over like Bart Simpson on the board?
Yeah, sorry, that's what we call it.
Okay.
We'd get lines. You have to just repeat some lesson.
Where I grew up, getting lines meant mirrors and razor blades, and I don't want to confuse people.
Okay, yeah. Well, I'm not as rock and roll as you, Brian, as obviously.
Fair.
Okay, so programs then that write programs. What's some good use cases for that? What sort of problem does that solve for us?
So my favorite is when you have a pattern that you want to apply to a problem set, and you need to do that over and over. You need to treat a particular resource a certain way. And it's going to be the same for all the resources. There isn't exactly a generic way to do it, but it's such a cookie cutter approach that you can write some metadata and then use that metadata to introspect the problem domain and then generate code.
Yeah, I've used it before. I had a data structure, and obviously Go doesn't yet have generics, but I had a data structure that I wanted to support multiple types. And I wrote a little program where I could just give it the array of types that I wanted to support, and it would generate the code for each type. So I got strong types, but I didn't have to write out every version of it.
I mean, Go generate is the only generics we need in Go.
Oh boy.
You said come armed with an unpopular opinion. There's mine. We don't need generics in Go. Generics make Go harder to read, and they're going to decrease my quality of life as a Go programmer.
Okay.
There's my unpopular opinion.
Okay, we do
tweet that up. Put it on Twitter. That's my unpopular. Generics will decrease my quality of life.
Yeah. This is a sort of rock star. I'm struggling to deal with the rock star. We've got a dedicated segment for unpopular opinion.
No, I do things the way I want to do things. I'm OG. Go time.
Well, we're here to learn. Okay, great. Interesting. So, do you prefer code gen then to generics?
Very much so. Yeah, I love code generation. I think it's a great way to solve many problems. Not every problem can be solved with code generation, but a lot of times you find yourself in a position where you have to do a similar set of things for a similar set of resources. And code generation is a great way to make sure that problem is solved consistently.
Without even getting in, sorry, I was going to say, without getting into the generic stuff, for me, code generation probably first popped up when I was looking at things like APIs where people connect with different programming languages. And Swagger is probably one that everybody's heard of at this point, and probably like the ideal use case for code generation is you have this API that you communicate with JSON and HTTP, and nobody wants to go write a library. Like if you're a company and your whole company is written in Ruby or something like that, you don't want to have to go write libraries so other people can connect to your API in every language under the sun that you probably don't know much about. So code generation is like an awesome tool for that type of use case too.
Protobuff uses code gen. I think in general, serialization, like if you want it to go fast, that's a really good use case for code gen, because you can do it with reflection. And I don't think generics is really going to replace any of that. But if it's like a core part of what you're doing is serialization and deserialization, then having code gen can make it far easier and far more maintainable to kind of write and maintain that code.
So that you can have a struct with proper typed fields in there, and they can be set directly because you sort of know in the meta sphere, what those fields are. You don't have to do reflection and other types of magic to wire that up, that kind of thing.
Yeah. So like in a Marshall JSON or unMarshall JSON, instead of like throwing it into the encoding JSON library, it's like, hey, go use a bunch of reflection and figure out what all the fields are and then translate the names. You can just generate the direct code that will generate the JSON for you. And that is much, much faster than the reflection code. But also, specialized use case, most of the time, the cost of reflection there is not the bottleneck of your application.
Yeah, I find one problem that we have with code generation is that the code that gets generated tends to be quite ugly and difficult to read. It's kind of like, it's almost like you either have nice templates that you can read and maintain and manage, or you have nice output. I feel like there's a trade-off between the two. Has anyone found that?
I don't think there has to be, though.
It
think
used to be worse. Like, have you used it recently, Chris? Because, like, there was one point in time where it was really hard to remove white space. And I think all the templating libraries in Go have added, like, sort of directives to make that possible now. But I know there was a time where Matt was completely right that doing that sort of thing was really hard to do because white space essentially just caused issues.
Yeah. And step 2 was, step 1, generate code. Step 2, run Go format.
Yeah.
Yeah.
If you're generating Go code, absolutely.
If you're generating Go code. But there is a package out there by a gentleman named Dave on GitHub, github.com/Dave. And the package is called DST, Decorated Syntax Tree. And it is truly the most elegant solution I've ever found for generating beautiful code.
Brilliant. Yeah, because this is a gap, I think, in the standard library. There are packages in the standard library, and they've added new ones too to make it easier, but they're so difficult to use because I guess they're the tools that the Go build tools use. And so they kind of all powerful, but they seem really low level and quite difficult to get your head around. Like you have to do value, and it's kind of like reflection, isn't it?
Don't love that so much. Reflection isn't the easiest thing to do as a Go programmer. It's fraught with peril.
Yes, and we avoid it where we can.
I think the big thing that the DST package also brings is proper attachment of comments to items in the syntax tree. I think that's like the biggest failing of the AST package within the standard library is that you just lose all of your comments and they kind of just dangle all over the place.
Yes, that is a problem. Does the DST thing package, does that actually maintain comments, Brian? Do you know?
Yeah, it does. That was the biggest selling point that Chris was mentioning, is that it will keep your comments and put them back in the right place even after it's parsed the syntax tree.
Yeah, so that's great. Well, so that's like for using Go code as the source data, which you don't always have to do in code generation, I suppose. And also like the templates, Go templates, you can use those. So just for anyone that hasn't done this yet, really code generation is anything that outputs some code. But more specifically, if you use like Go templates, the text one usually, a common mistake is to use the HTML template, and then you end up with kind of HTML formatting happening in your code, which you don't want probably. So you'll take some source data from somewhere, which could be Go code, and then you mix that with a template, and then you can generate Go code. That's one way to do it.
But it doesn't have to be Go code that you generate. You can generate all kinds of things. Generate SQL statements based on a Go structure.
Right.
You can generate anything. And in fact, I gave a talk at Abstractions, the first abstraction conference in Pittsburgh in 2016 or 17, called Generate All the Things. And you remember the meme with the guy, the really awkward looking tech guy with the yellow and all the things? That was me, generating all the things.
Is that still
the
available?
Awkward part too. It probably is. I'll dig up a YouTube link for it and see if there's a link for it.
Yeah, we'll put that in our show notes.
But that talk was specifically about my intense love, my burning passion for having a DSL as a source of truth for your systems and generating the code from that source of truth. So if you want to know information about a type, you look at the DSL. If you want to handle that type with Ruby code, you generate Ruby code to use it, or you generate C# or Go or database code or whatever. But that DSL is a system of record for all of the information in your enterprise.
So I have a question for you. We've talked about this several times on the show, where in languages like Ruby or any dynamic language, you can dynamically catch, like if a method's missing, and then you can add code. Do you consider that code generation as well? Or does it have to be something where in Go, you actually have to spit out some Go code that can be compiled, because that's how Go works? So do you differentiate between the two, or do you kind of consider the two similar?
Well, I would say code generation, you're writing new code. And in Ruby, using something like method missing, that's more meta programming. Although they're really close cousins, I don't think they're exactly the same, but they're similar. If we have time at the end of the show, remind me to tell you about how method missing cost the state of Georgia several $7 million.
Yes, that's going in. That's definitely going in.
I do have to say, when it comes to code generating, specifically when you're trying to generate Go code, I feel like the text template package is actually kind of bad for that, and it's better to write actual Go code and then use the tools we were talking about to parse it and then kind of manipulate it that way and stamp it out. Because then when you're actually writing the templates, you're writing real Go code. So you get syntax highlighting, you get formatting that's really nice, you get compile errors and all of that nice stuff. Whereas when you're just working with text templates, it's just like, a little bit wonky.
So how do you do loops and things in that then? If you're going to iterate through a set of data, how do you do that in the Go code?
For range.
Okay.
I mean, since it's just like the templates too, right? You're just like taking the templatized code. Usually you have to wrap it in a function or something, but you're just like pulling out the guts of a function, and then your IDL or whatever will specify, and you'll have the glue code that'll be like, okay, now you need to like stamp this thing out within this function, multiple times, or within this, domain multiple times.
Right.
So it does look a little bit different than what templates look like, since you don't have that kind of inbuilt looping and variable assignment. But I think that can also help make it a little bit cleaner, because then you're kind of separating things out a bit more, and your templates can just be like, this is the prototype of what I want the code to look like.
Mm-hmm. Yeah, that's great.
That same person, Dave, who wrote DST, also built an application called Jennifer. Mm-hmm. And Jennifer builds on top of DST to help you generate code. Hence Jennifer, because what was a programming application without a great punny name. Mm-hmm. And Jennifer is my personal favorite tool for generating code, because it builds on top of that DST, and it lets you write functions based on the occurrence and order of syntax in your AST. So you're parsing your syntax tree and you find this particular node. You can write a function that generates code based on the state of your current tree. And it's really, really nice.
That is cool.
The cleanest generator I've ever seen.
So how does that look when you're writing the code? You have types like functions and there's like some kind of sort of DSL builder pattern type API or something like that?
It's really just types and functions. So you've got your AST, and you do some sort of walk. There's always a walking function where you walk the AST and you build up state. And as soon as you hit some sort of desired state, you've got the right number of nodes in your tree, then you trigger a function that generates code, because you have enough state. But those functions are things like AST.create function. Right. And each of those also takes a function as its as one of the parameters. So you have these nested functions, and it's very powerful paradigm, but it can be hard to follow. The first couple times you do it, you kind of tilt your head sideways and what the hell?
Yeah, so it takes a bit of getting used to, but it kind of any of this meta programming is a bit like that. It's a bit like Inception, where you've gone into someone else's dream, isn't it?
A bit, yeah.
A little bit.
A little bit.
Yeah, a little
Yeah,
bit.
I feel like the reflection package is a lot like that too, where like the first few times you use it, especially when you're trying to do something clever, like calling a function, and you're just kind of like,
Yeah.
what's going on? I'm very confused about what I'm supposed to be doing here.
So you're trying to call a function on a pointer type of a struct or an interface.
Yeah.
Have fun.
Yeah. And it's like, oh, I have these values, but I have to turn them into like reflect values. And how do I do that? And yeah, it's confusing at first, but I also feel like it's like once you understand the reflect package, there's a certain class of code that you can just write and become so much easier. I found there's like tests that I've written where I would have had to have like hundreds of lines of more code to express them. But since I know how to use the reflection package, I just sat down and wrote them out, and it was like 30 lines of code, and now I can like run basically any type of function that I want and assert values and all of this stuff.
Yeah, the problem is you don't know it's wrong until you run it, because of course, you know, it's abstract, isn't it? So it's not like you get the compiler to help you check the things you're doing make sense. There's a lot more runtime in reflection. But you know, if you like, I like writing tests. It's not so much of a problem. Sorry.
You like writing tests?
I love it. I actually sometimes that's all I do. Yeah.
Sounds pretty boring if they're all failing.
Good point.
No, I would definitely say that my experience with generation is kind of similar to my experience with reflection as well, in the sense that, Matt, you were saying you don't know if reflection's wrong until you run it. But I honestly felt like with generation, I was almost in a similar boat where I had to actually run it with like knowing what I wanted as the output to see if it did it. And sometimes it was just because I didn't understand something that was happening.
Yeah. Well,
but once you get it, it's easier. It just took a little bit till you actually made sure you grasped everything correctly.
Years ago, I wrote a package with a friend of mine called Jenny, and is it not to be confused with Mark Bates' package Jenny from Go Buffalo, where he just, as far as I can tell, just stole the name from me. But luckily for him, I'm not very litigious. But we'll see. If he keeps texting me the things he texts me, well, maybe that'll change. Anyway, this package did what, Chris, you were describing, where there was a special type. So it was real Go code, and it was just like an interface type, but it had a special name. And then it would the tool would process that, and then you were able to replace that type with other types. So it's kind of like generics, very lightweight generics. It's still used by people, but I don't know. I mean, but that's kind of a nice way to do that, because then, like you say, the real code, the source code, the template is real code. So anything you can do to help yourself in that way, and like GoFumt is a great one if you're generating Go code. Although I suppose if you're using that Dave/Jennifer package, it probably formats it for you, doesn't it?
It does, yeah. It outputs code in the right format.
Yeah, that's brilliant. Some people put code generation as part of their continuous integration build. I prefer it to be a developer time exercise. How does everybody feel about that?
Ooh, can of worms is open.
Are there any good cases for putting it in the CI? Because I feel like you want to run the tools to generate, and then run your tests, and then you push it, don't you? What's the use case for having the continuous integration generating code?
Salt and pepper push it? Yes. Come on now. You guys aren't that young.
Yeah.
So I would say that the biggest case against developer side code generation, checking in generated code, is the fact that you don't have any control over the tool used to generate the code. If you're using version 1.2 of the code generator, but you're expecting 1.4, then nobody will know that until some point later on. And using your CI environment to create a known good code generation would be the antidote to that problem.
Yeah,
but
interesting.
I don't know. You could easily play either side of that fence.
Yeah. Actually, I've been playing around with code spaces on GitHub, and that's essentially like gives you VS Code virtual environment. And you can, just by specifying a Docker file, you can actually like install all dependencies and things like that. So whenever that's a really interesting idea to have these controlled dev environments. It would address that particular problem. But what about Go generate? Because Go generate is a command that you have to run, like you have to run that explicitly, don't you? The Go build doesn't run any Go generates. Maybe we should just take a minute to explain what Go generate is for anyone.
We should take a minute for that. So Go generate is another magic comment. Mm-hmm. Yet another magic comment. Can we put that in magic emphasis? Another magic comment in Go code that does
we'll
something
flash it on the screen.
Non-programmatic that specifies a command to be run when a file is triggered by Go generate. So you type Go generate from the command line, and any Go code that has the Go generate comment will run the command after the Go generate comment. And that command doesn't have to be related to Go. It quite literally can be any shell command for your computer. So you could say Go generate Spotify open playlist. And every time you run code, it will open Spotify and play Guns N' Roses. So Go generate is literally just a trigger to cause a thing to happen.
Yes. By the way, everyone's going to be doing that now, aren't they? They code generate. Yeah, they'll probably play that song. We'll play your song probably from the opening of the show. Talking about code generation. I'd love that to pop out of my speakers every time I'm doing that.
Every time you're building.
Yeah. Could you do like a whole album, and we could have one for failed tests and
Sure.
Yeah, do the whole set.
So, well, you've got the Sweet Child of Mine covered. So I'm not sure if there's enough room for the two of us in this industry. I bow to your superior capabilities.
Oh, no. Okay, so are there any common gotchas or something that we should look out for when it comes to generating code?
Absolutely. Tests, 100% required. If you're going to generate code, then you need to have known inputs and expected outputs and test against those as a unit test. And then as an integration type test, a broader test, test that the code that you generate does what you expect it to do as well.
And would you say not to generate the test code?
I actually love generating test code. Right. So the question is, does the test code that you generate actually test your code? Who watches the custodians? I don't remember the Latin key custodian. I don't know. Who's watching the watchers?
Yeah.
So to make sure I'm getting this right, you're saying that you enjoy generating both the code that's going to do whatever you need to do, plus generating tests for that code. I just want to make sure we're all on the same page.
That's correct.
Okay. That's something I've always it's not that I've been against it. It's just I've always, I guess, veered away from it because it kind of, I don't know, it almost felt like I wasn't actually, how do I put this?
Don't worry about offending Brian.
I'm not trying to offend.
He's bulletproof.
It felt almost like those tests never actually failed or told me anything useful at the time I was doing it. So I kind of just stopped doing it at the time.
And that's the bonus of code generation, because you generate code that works because you've extracted it out of a pattern that already works. It's not like you start generating bad code and then you catch it by writing a good test. I always start, I shouldn't say you because I don't know what you do, but I always start with a pattern that I know that works, and then I abstract that into code generation. And once you have that, then you can write your tests against it and you can generate them.
Yeah, I feel like those meta tests, the ones you were talking about, either testing the source thing, the original thing, or those integration tests, I feel like they're extremely useful. Mm-hmm. Yeah, but I mean, it's very satisfying when you start doing code generation and you see it working with just one bit of data, one input, and then you just add all the data and suddenly you just see all this code being generated. It really is very satisfying, whether it should be or not. Don't you find?
Oh, very much so. My moment of eye-openingness, what do you call that? My aha moment for code generation was when I stumbled across Goa in 2016 or 2015, I don't remember. And Goa is interesting because most DSLs that you find in the programming world aren't written in Go. Go is not an easy language to use to write a DSL. You can use Go structs as the source of your code generation, but actual Go code functions, not pretty. Ruby, Python, beautiful languages for writing DSLs, but Raphael, who wrote Goa, found a way to build DSLs that was elegant. And when I saw that, I immediately demanded in my open source friendly sort of way that he take the template engine, the DSL engine, and make it generic so that it wasn't just Goa that you could write DSLs for. And he said, pull requests speak, baby. So that was the first thing I did. I took the DSL engine and made it generic so that you can create any DSL with the DSL engine for Goa. And that was it. I mean, I was so sold at that point, because you're writing what looks like a DSL, you're describing your system, and that builds a tree, a syntax tree that then executes code that writes code for you. And that code can be anything. I mean, you can go from the gamut of writing SQL IDL files all the way across the spectrum to writing Kubernetes deployment manifests with the same DSL. And that's brilliant.
Yeah.
Why wouldn't you do that if you could?
I think that's probably the big appeal for any code generation. Like Matt, you've mentioned Auto before, and you use that to generate both Go side code and JavaScript code to connect to it. And just having that idea of the developer only has to do something once is very appealing. I suspect that's also why, like, when we look at code generation, there are several tools out there for generating basically models to connect to a database. And I think that's appealing to a lot of people because they think, I don't want to write all this code that connects to the database. And I know people have mixed feelings about using something like that versus not, but it is by far one of the more common use cases I see. And I think it's because people are just attracted to that idea of, I only have to define this stuff once and then all the other code for it's generated.
Yeah, we have a question. Sorry, Brian.
John opens the ORM can of worms early in the show today.
I mean, it had to come up at some point. And it's interesting because the ORMs, they usually take one of two approaches. It's either we're generating some code, or it's like they try to dynamically, but I guess some languages dynamically, but sorry, let me take that a step back. The ORMs generally take two approaches when they're generating code of either the Go is the source of truth or the SQL is the source of truth. And I think that's probably one of the bigger, I guess, can of worms to get into as to which one's right and which one's going to cause you more problems down the road.
What's the answer then?
Personally, I guess it just depends. I've found more luck with things like I think SQL Boiler is one that takes the SQL and generates the Go code, and I've found more luck with that type of approach most of the time. But there are definitely cases where the opposite is easier. For instance, if you're taking somebody who's new to developing web applications and they've gotten some Go down, at that point, it's probably easier to use one that takes the Go and generates whatever it needs for the database side because they already get what the Go is. But it really just depends on, the team and what you're doing in that sense. I've definitely seen cases where if you have the Go stuff defining what the database is, and then some migrations or changes can be kind of tricky to, I guess, express correctly for some people, or it's easy to have some weird bugs like that where the Go code changes and the SQL doesn't necessarily change the way you need it to reflect that. But I don't know. I don't want to get into the ORM can of worms. I have mixed feelings about them. They're definitely a tool that I've found use for, but most people seem to hate them in the Go community for whatever reason.
There's no shortage of opinions in the Go community, which is really strange. Most communities don't have any opinions, but the Go community is full of them.
Yes, and we're all so cordial to each other too. Okay, yeah, there's another interesting use case I've seen for this. Ernesto Jimenez did it in Testify. So there's two packages in Testify for assertions. There's the assert package, And then there's the require package. And the only difference is one will fail immediately and the other will let you carry on and sort of collect failures up and present them all in one go. And a lot of people prefer tests when they fail to just fail at the first thing, and then you can just address that and then work in that way. So that require package is generated from the assert package. So it kind of guarantees that the two APIs are the same or similar enough, or, the same in the same way, different in the same way. I'll think of what the correct way to phrase that is later, and we'll edit it in. But I thought that's quite a clever. Yeah, thanks. Thank you. I didn't do any computer science, so I don't know what I'm talking about. Yes, that one. It's a nice use case because in that sense, you want to carry over the knowledge from one of those packages to the other and use them interchangeably. So I thought that was quite a clever way to do that. What do you think about that? Yeah, fine.
Yeah, brilliant.
Can't all be winners.
I mean, it sounds
brilliant.
like a good
Thanks,
use
Chris.
case.
We appreciate your opinion. Great job.
One of the interesting things for me about code generation is that I feel like you see a lot of, like, Matt's defining a case where he had one code and like one set of code, and basically it sounds like he didn't want to have to write it twice, which makes sense. And the simple solution is just, well, I'll just generate the second version. And now another approach to that would be to take the code and sort of abstract it away so that you have one thing that can be used in both cases. But at the same time, that requires some work. So it's interesting how people use it to solve different problems, that it's not like it's the only solution, but it's definitely a solution to the problem.
Yeah.
Yeah, I feel like code generation is one of those things like SQL normalization. You've got n levels of normalization in SQL, third normal, fourth normal, fifth normal form. Code generation is kind of the same way. The level one of code generation is taking this template and plugging in a variable here or there and spitting out some code. Level two is, maybe throwing some if loops and some statements in there. And when you get all the way up to level 5, you're introspecting the whole system, determining the needs of the many versus the needs of the few, and generating only the code that needs to be generated. And that's a different level of code generation. You're on a
that's
different
true.
plane.
Have you ever seen code that generates code like that sort of?
I've written, Aaron Schlesinger and I wrote code that generates code that generates code. Wow. And it was a lot of fun.
Wow. Is that easy? Is it difficult to follow?
It was, it just takes a lot of iteration and patience. I wouldn't say it's hard because it's no harder than writing any other code. It takes a lot of time to build up small layers of success so that you can have bigger layers of success.
Yeah,
lots of like mental gymnastics in that too, to figure out like which layer you're sitting at as you're like generating. You're like, okay, wait, am I doing this correctly? Am I in the right spot? Am I thinking about this in the right mind frame? Like, I think that is one of the big challenges of generating code, is not the like actually writing the code gen itself, but just wrapping your mind about what you're trying to do, because it is so much more abstract than just like writing out code by hand, which is also what makes the reflect package like also very complicated to use, because you're not using the same utilities and handles that you're used to using when you're writing Go code.
Yeah, and that was the big pull for me from Goa, because I was writing a DSL about my expectations of what I wanted when I was done. I want a web service that listens on port 8080, that exposes this API with this resource, that has these methods, and it returns these fields, and it expects this authentication. There's nothing in that about how I'm going to do that. There's nothing that says I'm going to use GoKit, I'm going to use this middleware here. I'm just writing my expectation, and then the code generator does some stuff, and hopefully the code generator meets my expectation. But if it doesn't, I can change the code that's generated until it does. And that was the power of expressing what I want. It's like test-driven development. When you think about it, you've written your desired outcome first, and then you just keep writing code until it's green.
I think that like IDLs and DSLs are like a kind of unexplored space. I think not just in Go, but like across the industry, where there's not a lot of like emphasis and effort put into like designing good like standalone IDLs, but I think that's also crucial to using code generation well, because I know in the past when I've tried to like write some code generation, I usually start with like, oh, I'd like to just use Go and then like decorate a struct with a bunch of stuff. And I've always wound up at just like, I should just write a custom IDL or DSL in like some serialization format and then just use that as a source of truth, because now I'm like getting all of this stuff mixed in of like, okay, well, I have to like parse this package now that has and look for this special Go type and then introspect it and then generate code based off. It's like just read in an IDL file and then use that to generate everything. But I feel like when you get into that realm, you're getting into like the, okay, now you either have to like pick up a serialization format that exists like YAML or JSON, or have to like go write a parser, which is like getting in even deeper if you want to have like a truly like customized IDL that you can use.
But the question is, how deep do you need to go? I mean, do you have to write a parser? Do you have to write your own IDL? You know, if there's one small problem and you just need this little bit of metadata, then throwing a struct tag on a struct in Go and then inspecting that, that's the solution. Even though it's the cheapest and easiest way to do it. What's wrong?
I mean, absolutely. I think there's like levels. I think there's definitely levels to this, right? Where it's like, if you're doing something like if you're making like, say what's it called? Stringer, which just like, you know, takes a number of enumerated things and then makes the string output for them. If it's like a UN or whatever. I think for that, it's like, you know, it's relatively simple and straightforward and you don't need like an IDL. But I think when you start to get into like the really bigger code generation systems, I think it is kind of good to shift away from trying to like shove everything into Go. And I think there's a point where you start really feeling that friction, and when you're like, I don't think that this is quite right. And I think that's the point at which you should like make the jump. I don't think you should really start with designing your own IDL or DSL or serialization format. I think those are things that take a lot of time and expertise to do, and you don't want to be like learning that while you're also trying to figure out how to do code generation well. I think you have to like take your steps. But I think it's a very important thing to recognize that at some point, if you're doing a lot of heavy code generation, what you started with is likely you're going to outgrow it, and you're going to need to do something different, and just be prepared for that.
Yeah, and it's one of the most fun things and rewarding things I've ever done as a programmer. So I would absolutely recommend start as small and simple as you want to, even if it's just a tiny little template that you're using to generate other code, and just grow with it. It's fun.
I feel like both metaprogramming and code generation, to me, always felt like I was cheating or like pushing the limits of what I was supposed to be doing. Like it never felt like it's almost like I had to be secret about what I was doing, because it's like if other people see this crap I'm pulling, they're going to be like, what is this guy doing?
Really? You felt naughty?
It felt kind of naughty in some cases, because you're doing these things that are like well beyond just writing, you know, your traditional code of like, oh, I can see exactly what it does. When you're generating code, it's this weird, I don't know, it felt kind of naughty for some reason, but it was also just really cool seeing like how you could push the language or, you know, the limits of what you could actually achieve, and trying to ask yourself, well, can I do this? And sometimes, at least for me, I wasn't that productive some days, because I would go down some rabbit hole just to see if I could do something, not because I needed to, but because I was like, can I do this?
Yeah, but that's all right. I think you're a good boy for doing that, to be honest.
Rebel.
I think that's actually like something we need to do more of, really.
Yeah.
Is like, so I think like the only way that you can really acquire these skills is by going through and like actually practicing them, and actually like using these libraries and packages. And if every time that we have like a small problem where you're like, okay, I could solve this with reflection, or I could solve this with code generation, but I could just write these 150 lines of code by hand and it'll solve this problem now. If you always choose to write the code by hand, then you'll never have the skills to actually use these packages. So when you come into a big problem where you do need these heavier tools, you're just kind of stuck, or you're lost, or you're just going to take up an exorbitant amount of time like going through and not using these tools. I know that I, at multiple times in my career, have like been able to lean on my ability to use the reflect package and Go to like save myself tremendous amounts of time and tremendous amounts of stress. But that's only because I sat down and actually pushed myself to like use the reflect package, even there could have been like better solutions, or it wasn't going to give us huge gains. And I think that's something we as software engineers need to get a bit better at is not trying to always optimize for right now. So I feel like we do a lot of that. And I feel like that's usually the argument against this type of exploration is like, oh, well, you could have saved 4 hours if you just hadn't done that thing, or we could have saved some time if you just hadn't gone through and done that exploration. And I think that also kind of pulls us back into this frame of overly focusing on code. Like, I think what you said, John, there about like it feels like you're cheating is I think like it adds a lot of color to how we as engineers approach what we do, right? We focus a lot on the code. We focus a lot on the actual work output there. But I think software is about so much more than code, right? We have to like write design docs and specifications and all of these other things. And I think the more that we start to pull ourselves away from that intense focus on code, the easier it'll become not to only do these code generation reflection based things, but also to like get to the more promised land of like writing more comprehensive design docs that can solve bugs and solve problems before we even know that before we even written code and we have some maintenance nightmare to deal with.
I like to look at it this way. I am so lazy that I'll spend 3 weeks writing a code generation system so I don't have to spend 2 days writing repetitive code.
Yeah, I think that's a fair point. It's funny, like this kind of idea of doing experiments and stuff. If you're in an environment where you're constantly late, like the projects are constantly late, usually because people in the past, or including yourself sometimes, have estimated it and you're just wrong because it's really difficult to estimate accurately. And so for no good reason, really, you're just late. And then there's no room for those kinds of experiments and things. So I think it also falls to managers and tech leads and people to make sure that there's space in teams for people to do those kinds of experiments. Because, one definition I read of creativity is making connections that weren't there before. And the more kind of fuel you can give that process, the more opportunity for creativity there is. So it's something I believe in a lot. And unfortunately, it's quite rare. I speak to people, I've been quite lucky, but I speak to people where, they're just always late. Everything needs to be done quickly. You've no time to do an experiment to see if the reflect package is going to be interesting. And also, if it then isn't the way you end up doing it, some people see that as then a failed experiment, which it's not. And in science, really, you only really learn from things when they go wrong, when they fail. Well, you learn a lot from them if they do. We have a tweet just come in, not just come in. I'm just trying to make this feel more live.
Wait, way to add the drama, Matt. Thank you.
Yeah. We have a
Breaking
tweet.
news.
Breaking news. This just in from someone whose username is very apt. It's Gen20. James Nugent says, to commit or not to commit?
Ooh.
More of a discussion point, probably. The first half of that was more Shakespearean than the second half. But what do we think? Do you commit your generated code or not?
Well, it's this discussion we started with, right? Do you do it at the developer's desk or do you do it at CI?
I feel like a lot of this just depends on the workflow you're working with, because like I can give you an example. I use Tailwind all the time, and it generates a massive CSS file of all this stuff. And committing that big thing doesn't really make sense half the time, because anybody who's running the app locally, like if I have a React app, the tool chain is set up to automatically generate that anytime a file changes. So at that point, committing that just doesn't make a lot of sense. Now, eventually, if you're deploying, you have to commit whatever the cleaned up version is that you're shipping with. But for the development side, I would say there's no reason in the world to commit that. But on the other hand, like if you're generating, I don't know, it's almost like if you have a library, like you were saying, Testify, and they generate code. Well, they pretty clearly have to commit that. Like somebody has to commit that at some point. Now, when it gets committed is kind of up in the air, I guess, whether it's your CI tool or developer, but it definitely depends on your flow of how things get generated. Yeah,
but you need it locally. So you will always generate it locally, right? Probably, because otherwise you've no way. I mean, that's like committing. That's like fire and forget. If
you didn't need it, why are you generating it at all?
Okay, so yeah, you do need it locally, and then then toolchains. That's a good. The Tailwind's actually an interesting point there, because
I feel like there's this line between like is what you're distributing code, or is what you're distributing like a running application? So I think if it's like a running application, as John just kind of mentioned, I think in a lot of ways it makes sense to do the generation at the point where, you know, you're actually going to be running the thing. But I think if you're like a library maintainer, it's much better to commit the code. So I think, you know, I think that's one of the things behind Go Generate and why it runs the way it is, because it's like that the person who gets your code might not have the generation tools or the version of the tools that you're using to actually be able to successfully generate the code. So it makes library usage a lot harder if the person using the library has to do this code gen now.
Yeah. Yeah. And you want people to be able to check out the code and run it and build it, don't you? You don't want those extra steps. Yeah. So,
and if you don't have developers checking in the code, what you end up with is Bazel.
Right.
You have to boil the entire ocean every time you want to build a tiny app.
Yeah.
And that's what Bazel is. It's an ocean boiler.
Yeah, that's why I see code generation as a dev time exercise, for that reason, and others. This just in, I have another one from a website called Twitter. And this is from Tobias. And Tobias asks, how would you generate code split into multiple files or directory to get you started for new projects or parts of projects? So has anybody seen code generation for like bootstrapping projects? A bit like how Rails used to have that Rails generate command.
So one of my first forays into code generation was a tool called GenKit that generated a GoKit microservice directory structure for you.
Right.
And it was like first level code generation with ugly templates and, you know, struct tags, and it worked really well. You could generate all of the boilerplate that you needed for a GoKit microservice. And that included many directories and many types. And, you know, it was very inelegant, but it was also very efficient. It took me a half a day to write it, and it worked really well.
Yeah. So what can you ask for?
The opposite end of that spectrum is Goa, which, you know, the DSL doesn't take long to master at all. And it will write code across dozens of directories if that's what you want. But the background behind it is, you know, there's a lot of code behind that.
Yeah.
I feel like this question is like sneakily asking us how we would design a framework.
Buffalo.
Because like Buffalo or something, because it does kind of sound like, you know, how would you structure it? That basically comes down to what would your framework look like at that point?
Yeah.
And if you're interested in examples of that, Buffalo is a good one to go check out. It generates everything. And then, you know, there's much smaller tools like GQL Gen, I think, is one that just generates the GraphQL components. And then you're still expected to connect everything to that. So there's completely different takes on that you can look at. And I think it kind of just comes down to what you need for your project. Because there's definitely cases where Buffalo is a great fit. And there's definitely cases where it probably wouldn't be my first tool to go to.
Well, Buffalo is a good example of solving a problem and then abstracting that solution out into a more generic toolkit. And that's really where code generation shines for me, is once you've got that problem solved, generate the code to solve it over and over.
Yeah, that's an interesting point that you've made a couple of times, Brian. I think it is something that is worth people considering, because even if you know you're going to use code generation to solve a particular problem, you still ought to solve that problem yourself first. A bit like when you have a sense that there's a cool abstraction just waiting to be discovered. It's worth solving the problem, really solving it for yourself first, and then having a look to see. And in fact, sometimes doing it a few times, actually. I think that's quite a nice point. Chris, what have you done actual code generation yourself, and what sort of use cases did you use them for? Do you remember?
Yeah. I think like the last big thing I did code generation on was when I was working on the MongoDB Go driver, and the kind of wire protocol level was like very kind of normal and regular. And I was like, I keep writing the same code over and over and over again. This is really annoying. It's like slightly different things for like, oh, like this command is slightly different than the other one. So I just wound up starting off with like just writing the structs and then generating all of the methods that I needed off of them. And then I actually wrote an IDL format, and I was like, okay, now we just have these IDL files and we generate all of the implementation based off that. So it's like one of the things I've used code generation for in the past. But I've used it for a lot of things that are like similar to that, where it's like, I could write and maintain all this code by hand, but it's very tricky and everything is very regular, and it's going to be really difficult to find bugs if I try to maintain this by hand. So it'll be like small typos here and there will like completely break. But if it's not, in the case of the Go driver, it's not a used command often, then it might only break like when it's out in production already, because we don't have a good way of testing that already because of other things. So I think like that's how I've used code generation a lot in the past. I think to kind of respond to this tweet too, I have a kind of split way that I feel about this. Like I think that these types of tools that generate scaffolding and whatnot are good and useful, but I also very much dislike that we use things that are so general and generic that we need all of this boilerplate in the first place. Like I feel like it's somewhat of a failing of design here, because I feel like I've run into these same sorts of situations before when I'm trying to design something. I'm like, oh, there's a lot of boilerplate, and each time that I've done that, I've just sat down and spent probably considerable amount of time figuring out why I'm writing so much boilerplate. And usually at the end, I figured out like, oh, my design didn't quite fit properly. And I feel that's what a lot of frameworks wind up doing, is that they try to be so generic and encompass so many things that you need all of this boilerplate to just get the thing that you could have written with fewer lines of code if you just wrote the more specific code. Like I think configuration library is a really good example of this. I've written multiple configuration parsing libraries that wind up being less code than if I had used, which is it, Viper? Yeah, Viper.
Oh, don't get me started on Viper, Chris. Viper used to be the cutest little tiny configuration thing, and now it's the biggest monster. And I'm responsible for a good amount of that sprawl because I added the remote configuration so you could pull configuration from console and etcd. I added that to Viper, and it turned Viper's binary from this big into ginormous, and it's a big ugly mess of code. And I did it. I did that.
Well, welcome to therapy. Thank you for attending.
Who taught you how to smoke weed like that? You did, Dad.
Okay.
But I do think that like for where we are right now, having these code generation tools does make it easier for people that are like, okay, well, I have to use this framework because of other reasons. Let's at least make that their life a bit easier. But I do worry about like the kind of let's just generate all of our structures, because then it's like I go and open an application and there's like a little bit of a nice thing about when you open like a well-structured Go project where you're like, I can see where all the things go. I understand. I can see what this application is doing. But if you start having all of this hierarchy and structure, it becomes like, oh, like I can tell this is a Rails project. I have no idea what it does, but I can tell it's a Rails project or a Buffalo project or whatever project. I can tell that it's this thing, but I got to go do a whole bunch of extra investigation to figure out like what it actually does.
Yeah, that's a good point. There's no opportunity for storytelling, is there? If all the structures look the same, because that's the thing. When you have package structure, good package structure tells you a story at a glance, doesn't it? That's
Amen.
A great point, Chris.
Amen.
Yeah. Yes.
I don't want to throw a particular static website generator under the bus, so I'm not going to mention Hugo by name.
Okay.
However, I had this idea. I wanted to play with Go 1.16 yesterday. It was yesterday. And I have a Hugo blog, because Hugo really, truly is a fantastic way to build blogs. It's a wonderful way to turn Markdown into HTML. It's opinionated and it's fast and it's wonderful. But I thought to myself, I'm gonna use the embed package in Go 1.16, and I'm going to use something like Gin or Echo, some quick little router framework for web apps, and I'll just go steal the code from Hugo, or go import the code from Hugo that parses my Markdown and use the same templates that I already have. I'll embed that into the Go binary, and I'll ship a web server version of Hugo. That's all embedded into the same thing. I dug into the packages of Hugo's code, and I spent almost an hour and a half just finding the one thing that triggers the functions to execute templates.
Right.
Thousands of packages, thousands, maybe millions. Children died.
Yes.
I do feel like that's a thing that happens though when you start to get like bigger and bigger libraries, is that all of a sudden finding really simple and straightforward things becomes like an archaeology experiment. Like I remember like digging around in this is probably like the example of examples, but Kubernetes. I was like, how does this thing work? And I was like, okay, I guess I'm just never gonna know, because like the sprawl of packages that you can wind up with is just like insane. So I feel like it's like code generation good, but also like maybe we should make sure that when we are code generating that we're also like being good, citizens, and being good, helpers and maintainers, and making sure that new people can kind of get in and start to understand how things are structured.
Yeah, that's definitely true. Another thing happens in open source as well is when projects get popular, suddenly everyone wants to contribute to them, which is great, but that's then what you see happening. It did happen to Hugo. I must agree, Brian, because it started off, it was kind of tiny and it couldn't do that much, and that was sort of really easy to use. And it is just a trade-off. The more features a thing has, the harder it is to use, and it's sort of by almost its nature, unless they're just more capabilities within a certain direction, like just adding more, say, storage providers that it can support. The idea is still the same of storage providers. So that's quite a nice way to scale out a project. It's when things start to do more and more things. And, Ben Johnson, he recently has his project, and he said, no PRs, no contributions, please. It's an open source project. You can use it. I think he lets you open issues to report bugs, but he doesn't want code contributions because it's a hard problem to solve. It really is.
Yeah, I really respect that. It probably took a lot more courage than we're willing to admit to come out and say, I don't want your PRs.
Yeah.
But Ben is a really smart guy, and he went through this with Bolt DB, and I think that learning experience taught him quite a bit about how to manage that open source. So you're welcome to the source code. It's open, but you're going to have to fork it if you want to change it.
I feel like that should perhaps start being the way that we interact with open source more. Like, I feel like, as we just mentioned with like Hugo, like how many of those things did we actually need in there? How many of those things do people actually use? Do most people actually use? And would it have been better if we kept Hugo simpler and just made it more extendable, or made it easier for people to like fork it and add the things that they needed to add? So I think, my experience as an open source library maintainer is that there's just a lot of drive-by PRs, and you put a lot of effort in, and you have to put a lot of energy into like explaining to people like, hey, this is why like we really wish we could add this feature, but we can't, or hey, we can add this feature, but we have to do it in a different way. I read Ben's article about like why Lightstream is, open source but close to contributions, and it really resonated with me, because it's like it does take a huge amount of emotional energy and time to take contributions, and I think a lot of the time it just doesn't wind up being that kind of, it doesn't wind up paying off for the maintainer, and sometimes for the community as a whole.
Yeah. I like that phrase, the drive-by PRs. I think that's kind of really, really cool. I don't know. I don't get drive-bys. You're not even meant to be texting. We mentioned earlier the Go Embed new feature in Go 1.16. Next week, Mark Bates himself will be joining us to discuss that very topic.
The Mark Bates?
Yeah, that's the only one we could get, unfortunately. I did try and find alternative ones that were nicer, but unfortunately couldn't find any. So it has to be that one. Yeah, sorry.
I think that Go Embed is actually something that I've been wanting to have for a while when it comes to code generation. So I think when you I've had tools where I like distribute them to people like internally within our organization. And one of the challenges is always like, how do I get the templates where the templates are Go code or like text template, like into the binary that I'm shipping to people? And I like that now it's like part of the language. It's a language feature that enables you to do this, because I've definitely had some spend a lot of time with people just being like explaining like, okay, this is how you compile this tool so that you can use it. And I think that, having Go embed there will just make it so much easier. You don't have to do anything special to make it work.
Yes. And if you want to learn more about Go embed, tune in next week. As that's my radio, professional radio bit.
Nice.
Thanks.
So we got to let Brian finish his therapy session
by
going into his unpopular opinion.
Yeah, I think it's time. It's time for unpopular opinions.
Wait, don't we still have to hear about how, what was it, Georgia lost a lot of money?
Yeah, method missing. Method missing. So it's a long story short, a developer that was working for me in Ruby on Rails wrote a CMS, content management system, using SharePoint as the backend, which on the surface seemed perfectly normal because it's a place to store data, and why not? But there was a method missing call that was added to the root of the content management system that automatically searched the SharePoint library for code that would match if there wasn't a specific data structure found. And couple that with poor permissions on the SharePoint server, and 1.5 or 2 million Medicaid recipients had their data breached because of method missing, and that caused way too much pain for the company that we worked for and for the state of Georgia. And it's something that you can't easily catch in a code audit because the code was technically correct. It was the SharePoint server that was misconfigured, but the code put us in a position to take advantage of that misconfigured server. It's just danger, bad.
You'd rather have an error, wouldn't you?
I would much rather have just 404 on that web page than serve up an Excel spreadsheet with 1 million members' social security numbers.
Yeah. What were those numbers? Do you remember any of them?
I've got them written down. I'll send them to you later.
Cheers. Okay, well, we did hear your unpopular opinion earlier, Brian. Do you want to elaborate on it, or do you have any others?
That was well over an hour ago. I don't even remember what it was.
You don't want Go generics?
Oh, yes, generics. I really don't want Go generics. I feel like Go is a wonderful language without them. And one of the core features of Go is that it's easily readable. Go is optimized for readability. Adding generics reduces that readability significantly for me.
Really? Somebody on Twitter replied to me, I won't say that person's name, but they said, WTF, has no Go programmer ever worked with generics before? You are behaving like kids.
Somebody said that?
Somebody said that. I'll send you that. You might get on with that person, Brian.
Maybe. I mean, I like generics, don't get me wrong. I just don't like them in Go. I love them in Rust. They're perfect. They work really well. But I don't write Rust code to be readable, and I don't have the same level of productivity in Rust that I do in Go, because I can read my Go code really quickly and figure out what's going on.
Yeah,
I have a very rough, still developing analogy that I've been kind of shopping around with my friends about why I find some of us want the desire to have generics so much a bit ridiculous. And it goes a little bit like this, where it's like, okay, well, it's kind of like saying that you can't write a good story in German because German has gendered words and multiple versions of the, and English has this generic the that we have and no genders for most of our words. So it makes English a better language for storytelling because of that. And that sounds, pretty inherently ridiculous because, your story as a whole has much to do with so many other things that aren't related to like the nice syntax of the language that you're using for it. And I think that's like a lot of the case with Go, where it's like we are a successful, or this is a successful language, and we've gotten this far without generics. And that's not on its face a good reason to not have generics, but it also kind of tells you that like maybe at the end of the day, these won't be the things that we need, or the kind of golden feature that we really need to have to make the language even better. But I also definitely agree with Brian on the kind of cost of generics, which I feel like is not. I feel like among experienced Go engineers, that's talked about a lot, but it's not talked about a lot at large, where it's like, and a lot of my code reviews, and I think Mitchell Hashimoto tweeted out about this, of like, now he has this standard thing he's going to have to put in his code reviews, where he's like, does this really need to have generics? And I think a lot of us are going to spend a lot of time looking at code that has generics in it, and have to go and explain to people like, well, do you really need to have generics here? There's probably a better way to do it. There's probably a cleaner way to do it. We don't really need to have this, and having like lots of back and forth conversations about generics now that it's going to be in the language. And I don't really know how much of a benefit it's going to add outside of the like, okay, we've written some container libraries that we now have to use. Great, now we have this for generics. But where else is it like really necessary and was causing a lot of pain? And I just don't think, I think in the first like 5 years of us having generics is going to be a big net negative on the language ecosystem and Go engineers.
Yeah, I think I did a talk at Gotham Go called Things in Go I Never Use. And it was kind of the same idea of even like things we already have, and this idea that a smaller language footprint is better. So there's things that I just happen probably never to use very often. I think it's going to come down to that a little bit. We do have to be careful. We have to educate, because it's really people that come from other languages, I think, straight away are going to solve problems maybe with generics immediately. And we're going to have to, there will be an education, I think, to make sure that we're using it in the right way. But it's the same with code generation. I mean, you can abuse that too. We do.
I think it's exactly like code generation and reflection and all these other things, where it's like, I think channels goes in this too. It's like, we don't need to use them most of the time, but when we do need to use them, they are very useful to have. But it's difficult to figure out when and why you should be using these things. And it takes a lot of time and experience. And while you're building that time and experience, there's a cost that you have to pay for having those things in the language. And it feels like we've just like, we're adding another one, like another big one. That's like, okay, now we're just going to have to, teach a lot of people about like, and figure out as a community, like, how do we wind up writing Go code that still feels like the Go code that we've had in the past, with this new feature. And I think that's just going to take a lot of time and a lot of effort, and it's going to cause a lot of stressful things for people.
What was the big Mozilla data processing library? Really early on. It was one of the first big learnings that GopherCon brought for me specifically, was that channels aren't the answer to everything. And I wish I could remember the name of the library, but there was a big data processing library written in Go, and they use channels everywhere. And it didn't scale. Once they hit a certain threshold, channels aren't the answer.
Yeah, it's fair. I mean, I'm guilty of this. When I learned about channels, I loved it, and because I saw some example cases where it was used brilliantly, and then I overused it. And it wasn't that it didn't scale in my case; it was that it was hard to follow what was happening. And then I started just using a mutex. And I tell you what, just saying lock and unlock is very clear. If that's really all you need, it's kind of perfect. Yeah. And I even, when defer used to be slow, I would even just defer the unlock sometimes. So it wasn't really about performance for me. It was about the readability. But yeah, sometimes just a mutex is very, very powerful. Yeah.
I guess I have mixed feelings about this, because on one hand, it kind of sounds like part of the argument is we don't want to spend this effort on education, like educating people why they shouldn't be using generics. And the same could technically be said of channels. Like there are definitely a lot of cases where new Go developers need educated on why channels aren't something you just throw in every bit of your code. And I definitely agree that there's going to be a cost, and there's going to be opportunities for either somebody to make research, like books or whatever, that help educate people around when generics are actually a good fit versus, okay, you think you need generics here, but here's actually other ways to solve this problem. And I think once that sort of hopefully comes into place, there are some good solutions or possible, or not solutions, but good resources out there to show people how to avoid generics, then I think they're going to kind of fade off into like something you rarely have to mess with, but they're there when you really need them. And I don't know, I get the concerns. I guess I just don't feel like they're reason alone, I guess, to not add generics to the language.
Oh,
I do have it's not like a counter, but I guess just like another perspective on this as well, because I think it's like it's never kind of just like, oh, it's either we do this thing or we don't do this thing. There's always like, we do this thing and we're not doing a bunch of other things. And I think that's more of the problem for me, is that we have spent a huge amount of time as a community working on generics. And obviously, like, we can't force people to work on things, so it's not exactly like we should be working on something else. But I think we as a Go community, but I think also we as an industry, need to kind of do what I was saying earlier, of like start moving away from this obsession of language features and obsession with like, oh, well, this language doesn't have this feature, so it's not going to be good for writing software in, and start moving up into those higher levels of like actually writing better software and using higher level paradigms that aren't necessarily dependent on the language itself. And I feel like Go has historically been pretty good at that, because it is so doesn't have a lot of features. It doesn't, and the kind of extra features we do have in Go routines and channels, as we've been discussing, like, we don't use them a lot. They're kind of for special, okay, I know I need to use this here. I think that has done, perhaps by accident, is push people to focus more on the software itself and the thing that we're trying to build. And I think that my worry of us, it's not really about generics, I think, at the end of the day. It's just this like more focus on like, oh, well, we'll just like add things to the code, add things to the language, and that will fix our larger problems. When it's like, no, we have to get back to the like, how do we actually build applications so they don't like fall over? How do we build applications so they're readable and maintainable? How do we build applications so we can quickly onboard new people, so we can get more resources onto projects when it's necessary? And I think those higher level meta things are constantly being left out of the conversation, and we're not discussing them in enough depth. And I think generics is one of those things that just sucks more air out of that space.
Yeah, I think that's a great point. I wish we had more time to discuss generics in more detail, and we probably will on a future episode of Go Time.
Just don't invite me.
No, we need all the perspectives. Brian, if you leave Go because of generics, I've got one message for you, mate. You'll be back.
Yeah, bye. Bye, Felicia.
Just cuts off.
Can I have like a little tiny
yes.
Unpopular opinion I can just drop and run?
Please.
So my unpopular opinion is that estimating how long things are going to take is not actually that difficult. We are just so ridiculously bad at it that it seems impossible.
Okay, well, what's the difference really between those two things? If we're all terrible at it, why don't we just stop lying to ourselves and stop doing it?
I think the former is something we can fix, right? If it really was true that you can't estimate things, that it's like this impossible task we can't get right, then we're kind of stuck, right? Then you can't ever really fix that. We're just kind of stuck with like, I don't know, software will get done when it gets done. But if it's that we haven't developed the skills necessary to be able to estimate well, that's something we can work on. That's something we can fix. And I think there's writing out there, and there's things out there, especially in other industries, that can help us understand like, why is it that we are so bad at estimating how long things are going to take in software? Like, one of the things I always kind of talk with my friends about is how, like, I don't know, when's the last time that you factored in people's vacation schedules into your sprint planning? or like your quarter planning. Like how many times have you actually like pulled in a vacation schedule and had that be part of the way that you calculate things and not just been like a background thing?
Yeah, but never mind those things which you could factor in. What about all the stuff like that you learn as you start? That's the trouble for me, is as you start and get underway on something, you unravel so much stuff. And so you can get good estimations, but you sort of have to do quite a lot of work up front to get them. And then why don't we just focus on doing the work? And I'm not against like deadlines. I actually really like quite aggressive deadlines because it really forces you to prioritize. But it's not about like cramming all that scope, cramming everything into that short time period. You allow the scope to be flexible. You pick the most important, and sometimes that's the hardest bit. Is people want they want everything, of course, by the release date. But if you can't have that because of, I don't know, the laws of physics, then what would you prefer to have first? And that, even as a question, is a very difficult one. And sometimes the worst managers I've ever worked with will say, no, it's all top priority. It's all top priority. Like, because I'm saying, well, let's try and order this. No, we need it all. It's as simple as that.
I feel like our industry is like veered very much into the like being scared of doing anything up front. We're always just like, no, we got to like just get into it, just get into the work. And I think we've very much underestimated the actual cost of doing that. Of like,
a surprise.
Now we have all of this code that we have to maintain, and if we got this design wrong, then we're stuck with this code. I've worked on so many legacy code bases that are like, if you spent an extra 3 weeks just thinking this through, we would have had a much cleaner design and a much better thing. And I feel like software projects constantly run over by months and months and months, that like spending an extra 2 or 3 weeks up front to like sit down and really start figuring out and estimating and figuring out all the risks of what you're trying to build is well worth it. But we don't make that decision because that's like the bad thing. That's like waterfall if we start doing that.
VCs don't value planning. They value shipping and crushing it.
I agree with. Yeah.
That definitely seems like part of the issue is like the short-sightedness, I think, in general. It's like, I don't know. I've sat down with people before and I'm like, is there ever really a software like people are always just like, oh, well, this thing, we can do it in 2 weeks. We can do it in a month. We'll build this service in 2 weeks. We'll build this new feature in a month. And I'm like, when has it ever actually wound up taking only 2 weeks or only a month? Like never. It always like drags on and on and on and on and on. And then it's like 6 months down the road. And I'm like, well, we could have actually planned a proper project and been done with a good thing, good service, like a good feature at the end of those 6 months. But instead, now we're going to drag it in for another 4 months, and then we'll have like half of what we really wanted to have at the end. So I feel like the aversion to planning very rarely works out in our favor in the long run.
Yeah, I mean, there are for sure. It's one of those. It depends, isn't it? I think if you can, the thing is like. Quick prototypes and things like that are great for this because they feed into that process. Because you're right, of course you would if you can do the design, if you can think ahead a bit. I mean, that's really what our intelligence is meant to be for. Then we should do that. It's just, I mean, I think it's when it depends as well who's doing that design and the fact that. You need to have that mechanical sympathy with the system as it is today, and the changes you're going to make. Because without that, it's just too difficult. So I just think it is difficult. It's very hard, but there's definitely cases where a bit of design, a bit of thinking ahead, would have just saved a lot of time. It's just very difficult to know those instances. I guess that's where experience comes in.
I guess the way I would put it was with the limitations and like the current way a lot of management works, it's almost impossible to estimate projects. But if your management's willing to work with you to be like, I need a week to figure this thing out, like to do a prototype and to figure some stuff out in design, and then we can sit down and come up with a good estimate from that point. And if you have like a team that's like, it's not necessarily, I guess what I'm saying is it's not just learning how to estimate. Part of it is having a management team that's willing to let you figure out what you need to figure out, and let you actually learn the skills you need to learn to estimate accurately. And in a lot of places, they aren't willing to do that. So you're expected to estimate a project without doing any prototyping. And if you come back and give a realistic number, sometimes they're like, no, that's too long. You need it needs to be less than that. And it's like, well, you're expected at that point to just give them a less number, even though it's not accurate. Well,
I always say, well, what do you want to take out? And when they say nothing, you do have a problem.
I do think too that like, it's not just like, we can't solve this on our own. It has to be like larger, both industry and like, the other aspects of the organizations we're in all have to change to get away from this mindset that like, oh, we can just like pump out this feature without actually having to do the stuff around, all this like design. And I think at the end of the day, it comes down to like risk assessment. Like we have to sit down and actually assess all of the risks. And like, that really is like, not just like the things that could go wrong, but like all of the designs, all of the, the kind of prototyping that we have to do. We have to sit down and really put all of that at the forefront, like at the beginning of what we're doing, and continually do it throughout. But as you said, like we have to include management in that. We have to include both product management and like people management. Like this has to be something that we all do together, understanding that if we start doing this, the software we build not only will likely get delivered faster, but it will be of higher quality. So I think that's the other thing that happens is like, if we don't do this estimation, we won't succeed most of the time, which I think is the case right now. We aren't succeeding most of the time. We're failing most of the time. Like the software is so broken that we're all just used to like working our lives around it. We just refresh the page, turn it off and turn it on again. Like this is just how we do things. Because it's like, that's fine. But it's like, it's rooted at this problem where it's just like, we don't actually know what we're doing when we go to do it. And we just kind of wing it. And like in most other industries that like just doesn't fly and just doesn't work. Like imagine if you're building buildings, you're like, we're just gonna wing it. We don't need to sit down and come up with the blueprints and estimations of the resources this building will use. We'll just drop it on the land and hook it up to the public utilities and hope that everything works well. But that's quite honestly what we tend to do a lot of the time.
We'd have some great buildings though if we did let people do that. A lot of them had failed, but the ones that worked, imagine them. Actually. Yeah, Angelica Hill, another GoTime panelist, is actually a manager herself. So we are going to do a future episode where we dig into this. And I want to call the episode Managers, Do We Need Them? We'll find out. We'll find out. We'll solve that one. We are well over time. This has been a great conversation, but I need to do some host duties now. And basically get rid of you all. So, but thank you so much. Brian, maybe you could play us out after I do this final thing. You can play anything.
What do you want to hear?
Oh, whatever. Anything you've got, mate.
Whenever you invite managers on for that show, can you make sure you tell them the title, the working title?
No. Okay, thank you so much for everyone paying attention today. It's been an excellent episode. Chris Brando, John Calhoun, always a pleasure. And of course, Brian Ketelsen, what would we do without you? Thank you very much, sir.
So how long am I going to be blacklisted from being on GoTime after this episode?
It depends how good this performance is now.
That's a tough one. Thinking about Malagueña, Spanish wedding song. It isn't going to happen today. Sorry.
Ole! Brilliant.
That's what I got for you.
Excellent. And that plays out the song. That plays out the episode then. This is now the after party. So this is great stuff.
I gotta go to the bathroom, man. It's time.
You
It's
can stop
time.
the recording and upload all that fun stuff. I assume you have.
That's going in. That's going in. That has to go in. That's a great ending. Just we'll cut the song and then we'll just play that clip. I gotta go to the bathroom, man.
I gotta go to the bathroom, man.
I can't.
We're done.
Brilliant.
I do have a book recommendation for if anybody's interested in like learning more about risk estimation. It's called Waltzing with Bears. And it was written by the same two authors who wrote Peopleware. So it comes from that kind of pedigree. And it's all about how they like, because what they basically do and have done for like a while is do forensic project management. Will like, you know, there's a client and someone that's supposed to build some software, and for some reason someone is suing someone else, and they'll go in and like do analysis of the project to be like, okay, who's at fault for why this project failed, and they kind of go into like a lot of the detail of like why software projects seem to like always run over, always fail. It has a lot of really good like tidbits in there about like how we can do things better. I think like one of the big kind of takeaways I got from that book was the way that we do estimating when we do like story pointing is we always give the estimate of when we can't prove that it won't be done, right? That like 0.0001% chance of success where it's like, well, I can't really justify saying that I can't have this done in 2 weeks. So I'm going to say 2 weeks. But you know, if we always give our estimates as 0.001% chance of being successful, then we're gonna fail 4/9 of the time, which is not the kind of uptime that we would really want to have with projects. So one of the things I actually suggest is giving ranges of time instead, which is like give that time where you're like, I can't prove that I won't be done, but then also give a time that's like, I can't imagine if this project is still running. If this project hasn't been canceled, us not being done by this, and then kind of find a middle percentage, maybe like I'm 70% confident we'll be done by date X. And by having these ranges, you can then have a much richer conversation around like what you should do, how we should plan our timeline. And when you start taking these things and adding them together, that's when you start to get the kind of buffers you need. So if something does run over, well, maybe this other part of it is going to run under, and you can kind of make that up in your schedule. So there's tons of great stuff like that in the book, but it really kind of like opened my eyes to the like, oh, we could do risk estimation better. We could like actually have estimates that will be somewhat accurate of when we're going to deliver this thing. It's just going to like, you can't do it with story pointing. You can't do it by saying like, this is a 5. Like you have to have a lot more information and a lot more context. And then you have to importantly go back and review it. Like you can't also just say like, I think this is going to be done in June. And then if it's done in May, you need to go back and say, okay, well, what did we get wrong here? If it's done in July, you also need to go back and say, what did we get wrong here? Like you should always be trying to get to like the point where you can estimate things within smaller and smaller windows. Because it feels like the only time we ever really go back and review things is when things went catastrophically bad. We never say, oh, we're under our estimation, let's go investigate why. Like that seems weird to people, but like that's just more data that you can use to help you hone your estimation skills.
There's a startup in there somewhere for you, Chris. If you can solve that one. Great. Well, we should let Brian go to the lavatory, shouldn't we? Yeah, we should.
I just assumed he was going right now.
I don't know how much politeness we could keep him here for as long as possible. That'd be a good little experiment.
We're all gonna go in shifts. Like we're all gonna leave. But
yeah.
I really appreciate you guys having me back. It was wonderful.
It was. It certainly was. It was great to have you back. And come back anytime.
Awesome.
Yeah.
Except for the times that we're full.
Oh, John.
Not those times.
You said that.
The times we're talking about generics, not those times either.
Yeah. Well, we need those other voices, though, don't we?
Love
we
an
don't just
episode
want
that's just like
sycophants.
hearts and generics for the title and say, Brian, this is the perfect one for you.
Yeah.
We're all just writing poetry about why we love generics.
Cheers. Cheerio. Pip, pip.
Right. What? I do have to go.
Okay. See
Different
everybody.
reasons.
I'm gonna
Bye, everyone.